All right, welcome back to our second lesson. I guess you must like the first lesson very well. That's why you're coming back for the second lesson. Anyways, the second lesson is on factoring polynomials. Now, in the past, we've factored trinomials with degree of 2, so quadratics. But obviously, not all functions are, quadratics. Or not all polynomials are quadratics. So how do we factor polynomials with a higher degree? So that's what we'll be looking at today. Now, before we do that, though, we are going to quickly review of how to factor some of the examples here. Okay, so for the first one, for the quick review, we have 3x cubed minus x squared minus 14x. Hopefully you see right away that we have a common factor of x. So the first step I would do is factor the x. So that'll be x, and then we would have 3x squared minus x minus 14 left inside the bracket. Now there are many different ways of how you can factor. At this point in time of my math career, I suppose I'm just gonna guess and check. So I'm looking at, two numbers multiplied to 3. I guess that's x times 3x. And then I'm thinking, okay, so which two numbers multiply to 14? Well, I guess we have two options, either 1 times 14 or 2 times 7. I'm just gonna go with 2 times 7. Now, this again is just kind of guess and check. So you really need to play around with the numbers and then see if it works. Now I know the middle term means when I multiply, when I expand this and when I combine like terms, the middle terms will simplify to negative x. So if I put a minus sign here, that'll be x times negative 7, which is negative 7x. If I put a plus sign here, that's positive 2 times 3, that would be positive 6. Negative 7 plus 6, you can see, will be negative 1x that we have here. So this would be the factor form of this polynomial. Okay. Okay, for part B, this one is a special case. This is a difference of squares. You can see both 16x squared and 25y to the power of 8 are both perfect squares. So this is a special case, difference of squares. We're looking at what multiplied itself gives you 16x squared. That'll be 4x. And then we're looking at a term that multiplied by itself to give us 25y to the power of 8. That would be 5y to the 4. Okay. And this would be 5y to the power of 4. And recall, it's going to be a plus sign between and a minus sign between these two terms. So when they multiply together, you get 16x squared minus 25y to the power of 8. Okay, so these are some polynomials that we've seen in the past that we can factor, no problem. Now, before we get into factoring, there's actually a couple of theorems that we need to be looking at first. Then we can actually factor. Okay, so here's the remainder theorem. It says when a polynomial p of x is divided by a binomial x minus a, the remainder is p of a. Okay, so I don't know if you understand what's saying here, but it's actually very easy to apply this theorem. What we're doing here is we're looking for a remainder. Okay, so here, given that this is p of x, that is the polynomial that we have, and we are looking to divide this polynomial by the binomial x minus 1. So based on the theorem, it says if we're looking for the remainder, all we need to do is plug it in a into the polynomial. Now, if you look at this expression here, the value of a is 1. Okay, so we have a equals to 1 here. So to find the remainder, all we need to do is plug in 1 into the polynomial. So I'm just going to do it quickly here. Minus 1 minus 1. I really suggest you to put brackets around 1, okay, so to avoid confusion, because sometimes it will be negative, as in part B, you'll see shortly. So once we expand this, you should have 5 minus 3 plus 2 minus 1, which is positive 2. So the once, or if we divide this polynomial, 5x to the power 4 minus 3x cubed plus 2x squared minus x minus 1, if we divide that by x minus 1, the remainder would be 2. Okay, that would be the remainder. Okay, so here's part B. What if we divide by x plus 2 instead? Well, same thing. Okay, so what we need to do is we plug in this case though, negative 2, because in this case a is negative 2. Okay, we're looking at x minus a, but we have x plus 2. So a is negative 2. So put in negative 2 into the x cubed plus 2 times negative 2 squared minus negative 2 minus 1. We would have negative 2 to the power 4 is 16, and 16 times 5 is 80. Negative 2 cubed is negative 8 times negative 3 is plus 24. Negative 2 squared is 4. 4 times 2 is 8. Minus negative 2 means plus 2 minus 1. This will give us, what is this? 90, 114, so 113. So the remainder will be 113 here. Okay, so that's how you apply remainder theorem to figure out the remainder when we divide polynomials by a binomial x minus a. Now here's the follow-up question. It says, does a polynomial have to be written in descending order to use the remainder theorem? Recall from the previous lesson, when we do long division or synthetic division, we must write the polynomial in descending order. Do we need to write it in descending order when we use remainder theorem? The answer is no. Okay, we don't need it. We don't need it to be written in descending order. Okay, so here's the example practice for you to do. So click pause and give yourself a minute or two to finish the question. Okay, so I'm assuming that you're finished. So let's see, 2 to the 4 plus 17 times 2 minus 3. Here's the remainder. This is 8 plus 16 plus 34 minus 3, 55. So that's the remainder. For the second one, this is, oh man, that's terrible. This is negative 3 cubed plus negative 3 to the 4 plus 17 times negative 3 minus 3. Negative 27 plus 81 minus 51 minus 3. I believe this is 0. Yes, it is definitely 0 because I purposely set it that way. Okay, so here's the question. It says, what can we conclude with the practice question B? So again, the remainder is 0. What does that mean again? We talked about this last time. If the remainder is 0, we can then say that x plus 3 is a factor of the polynomial x cubed plus x to the 4 plus 17x minus 3. Okay, so if the remainder is 0, then we can say that x plus 3 is a factor. Now in other words, we could also say that x plus 3 is a root of the function let's say f of x equals to, or I guess we've been using p of x, so let me just make it consistent here. P of x, x cubed plus x to the 4 plus 17x minus 3. Now, do you remember what it means to be a root of the function? Well, basically, then when you graph it, then that would be the x-intercepts. And I mean, we can see that it means that x plus 3 is a factor. So this is key to factor polynomials with exponents bigger than 2. Okay, this is the key. We are going to use this. I guess we call this the factor property or something like that. I can't remember. I think it's called a factor property. Okay, when the remainder is 0, then there you go. It's a factor. So this really leads, well, then I guess the question is, then how do I find out what this is, right? How do I know if it's x plus 3? Or what should I try to plug in here so then I know it's going to give me a remainder of 0, right? What should I plug in to the function? And this, I guess, leads to the rational root theorem. It says the rational roots of a polynomial function must be in the form of m over n, where m is the factor, or m are the factors of the constant term, and n are the factors of the leading coefficients. Okay, so these give us the possible values for us to plug into the function. So, and hopefully this makes sense to you, but if if it doesn't, then I'm going to show you the example here. It says factor 2x cubed plus x squared minus 7x minus 6. Again, this is a polynomial. In particular, this is a cubic function, right? We have the biggest exponent of 3. So we have not done this before. But based on the rational root theorem, it says the rational root must be in the form of m minus n. So let's just list out the possible values of m. I'm going to write this more to the side here. And the possible values of n. Because we know the possible root, the rational roots, are in the form of m over n. Now m would be the factors of the constant term. So here our constant term is -6. So the possible factors of 6 would be 1, 2, 3, and 6. And the reason why I write it, separately is because it could be positive or negative. Okay, so it's really positive 1 and 2. Positive -1, positive -2, positive -3, or positive or -6. Okay. Now same thing for n. N would be the factors of the leading coefficient. So in this case, the leading coefficient is 2. So the possible values of n, or the factors of n, are positive -1 or positive or -2. So if we are looking in the form of m over n, there are several possibilities. Okay, so m over n could be either 1 over 1. Obviously, it could be positive or negative. Or it could be positive or negative 2 over 1, 3 over 1, 6 over 1. Or it could be, so I first used the m differently, and then I kept n as 1. Or I could now making n as 2 and then just changing the values of m. So it could be plus minus 1 over 2, plus minus 2 over 2. Now this really is the same thing as that one, right? Or plus minus 3 over 2, plus minus 6 over 2. Now that is the same as 3 over 1. So you can see there are actually many possibilities. There are, what is this? Well, these two are the same thing, okay? And these two are the same thing. Now that means we have 2, 4, 6, 8, 10, 12 possibilities. Now, that's quite a few. And I mean, given that the numbers are small, 2 and 6, I mean, we could get more. So what I would really suggest you to do is kind of take some easier numbers. I mean, I wouldn't try 1/2 or -1/2 or 3/2 or -3/2 first. Right? I would always try 1 and -1 because they are easy to do. Even if they don't work, it wouldn't take much of our time. Okay, so I would always try the integers first. So that's what I'm going to do. Okay, I'm going to try p of 1. So then all I need to do is plug in 1 into x and see if this gives me a remainder of 0. Unfortunately, this does not. Okay, this actually is, what is this? This is -10. Okay, that's not good. Well, that's okay. I can keep trying and see which one will work. I am going to try -1. I think this one is going to work. Again, by the look of this equation, I think has a very good chance that p of -1 will give us a remainder of 0. Let's see. This is -2 plus 1 plus 7 minus 6. which is indeed 0. So if this gives us a remainder of 0, and if that's the case, what does that mean again? Well, this means that x plus 1 is a factor. Okay, so right away we found our very first factor. Now, if you look at this equation, or sorry, this polynomial, how many factors do you think we will have? Well, because the highest exponent here is 3, there is a very good chance that there will be 3 factors. Okay, so probably 3 factors. Now, we found the first one. Now, obviously, we could keep trying and you know, hopefully we'll get more, but that's not the best way of doing this. I think the best way of doing this is then, well, then let's do synthetic division. Because by doing this, and because we're trying to divide it by x plus 1, so we put in -1. What this does is then it brings down this polynomial 1 degree lower than its original polynomial. Okay, so this right now is a 3rd degree polynomial. If we divide by x plus 1, is now then going to be 2nd degree, which is a quadratics, which we know how to factor, right? Okay, so then let's quickly do this synthetic division here. You multiply and you add them together, multiply and add them, multiply and add them. You can see the remainder is 0 as what we expected, and this will give us 2x squared minus x minus 6. Okay, so then again, this is quadratics, so we can factor this, no problem. It's probably going to be 2x and x here. We need to add to -1, so it has to be -2 and plus 3. Okay, 3 times -2 is also -6. So, and this is correct. Good, so that means 2x cubed plus x squared minus 7x minus 6 is equal to, now you can see we have our 3 factors here. X plus 1, this came from here, and then we have 2 other factors down below, and x minus 2, and these. Okay, so this is how we factor this cubic function. Okay, so again, let me just go through the steps. We need to first come up with the expression for m over n. Now obviously you don't need to write this down, okay, but I'm just trying to show you there are many different possibilities, okay. But what you need to do is take these possibilities and plug into the polynomial and see which gives you a remainder of 0. Once you've done that, then you do your synthetic division here, and that will take us 1 degree less, okay, or lower than its original question. So now this becomes a quadratic equation, which then we can factor easily, and that gives us the answer. Okay, so this is the cubic function. So here is the practice question for you to do. Again, you can click pause. It is a 4th degree function. Okay, we call it quartic function, or a polynomial. Think about how is this question similar to the example I just showed you, and how is it different. Okay, so click pause, and then good luck. Okay, so hopefully you finished the question. For this question, it is a 4th degree polynomial. Okay, so it is a little bit different, but the first step would be the same. Okay, so we will list, again, I'm going to do this, but you don't have to. Okay, so m is the factor of the constant, which is 1. I mean, so that's just plus minus 1, so that's good. For the 6, it could be plus minus 1, plus minus 2, plus minus 3, plus minus 6. So there are in total, how many is this? 8 possibilities. Okay, 1 over 1, -1 over 1, etc. And then 1 over 2, 1 over 3, 1 over 6. Now I wouldn't, again, like I said earlier, I wouldn't use 1 over 2 to try it first, because that's just not a, you know, it's not as nice as integers. Okay, so what I'm going to do is I'm going to try p of 1. Okay, that is my always, you know, all-time favorite number to try because it's nice and simple. Okay, so I'll do it quickly here. +1, I believe this gives you 0. Okay, I'm not gonna expand this. I know it's gonna be a 0. I mean, I made a question, so I know what factors are. Okay, so P of 1 is a 0. So once we know that, that tells us that x minus 1 is a factor, which then means I can do synthetic division. Okay, so 6, -1, -7, 1, and 1 divided by x minus 1. So that'll be 6, 1 times 6, -1 plus 6 times 1, add them, times 1, add them, times 1, and add them. So this tells me this becomes 6x cubed plus 5x squared minus 2x minus 1. Now this is still a cubic function, which we can't just factor like how we did it before. So we still need to continue with our remainder theorem or factor property. Now this time I'm going to try p of -1. Okay, so again, you might not be able to see it right away. I mean, I can't do it either, but I know the answers. That's why I know -1 is going to work. This is going to give me a 0. Okay, I'm gonna write it here, which means that x plus 1 is also a factor. Okay, so they are my two factors here. Now what I need to do is, again, synthetic division. Now if you don't like synthetic division, you can always use long division as well. Okay, there's no I mean, I'm not gonna force you to use synthetic division. 1 and 0, so this tells me this, what we have remaining is 6x squared minus x minus 1, which can be factored. This is simply 6, I'm guessing it's 3 and 2, and that'll be -1, and that'll be +1. Is this right? Yes, this is right. So now we have our first factor, second factor, third and fourth factor, which is what we should expect because it's to the power of 4. Okay, so we should have 4 answers or 4 factors. Okay, so that means our final answer is going to be equal to x plus 1 times x minus 1 times 3x plus 1 and 2x minus 1, and that would be our final answer. Okay, so this is our second lesson. That's it. If you have any questions, let me know. Okay, now the next lesson is 1.3 is, I believe, about graphing. So there will be no videos for that one. You just need to kind of try on your own. Okay, it's a lab. So well, that's it for today. I'll see you next time.